Alright, hello everyone, my name is Tan and I'll be giving a quick lesson on gas properties for Chem 2A from two multiple choice questions I happen to make. Alright, the first question is, a gaseous biomolecule weighing 0.310 grams occupies a volume of 150 milliliters at 25 degrees Celsius and 760 torr. What is the molar mass of this compound? What you can do on the exam is use the ideal gas law, also given on the formula sheet, but I also prefer to introduce this other equation that not only solves the problem for molar mass and density, but also ties into how those specific constants play a role in the gas properties chapter itself, as you will also see in the second question. And this equation that I'd like to show you is molar mass equals density times R, or technically 0.08206 times temperature in Kelvin over pressure in ATM. And from this question, we are given those constants. We'll have to find density as grams over liters. And as you can see, we are given 150 milliliters, which we will need to convert to liters by dividing this value over 1000. Which should give us 0.150 liters. And from that, we can be able to find the density as 0.310 grams over 0.150 liters. And then from this equation, we can ultimately find molar mass by the density, 0.310 grams over 0.150 liters, times 0.08206, which is our R value, times the temperature in Kelvin, so we'll have to add 273, and then divide the whole thing by pressure in ATM. We are given 760 torr, but on the formula sheet, you'll be given how to convert that, which is to divide by 760, which gives you 1 ATM. Here we go, I apologize for that. And if we're able to plug and chug into the calculator, you should be able to get the value of 50.5 grams per mole, roughly around this value as your answer, which makes this answer to be B for the question. That is one way to do it, and I'd also like to give you a quick way to memorize this equation because this is not given to you on the exam or the formula sheet. And it is molar mass kitty cat, which is basically molar mass kitty cat puts dirt over her pee, which is funny because it's also true. I also found it to be very helpful for memorizing this equation to just see how we can find density and also the molar mass of a compound through an ideal gas law. And this helpful mnemonic, molar mass kitty cat, will get you very far in this chapter for gas properties. Alright, now for the second question, which ties into the proportionals of how it'll be able to play a role in gas properties. As the molar mass of a gas in a sealed container increases, what happens to the density of the gas? Well, from this equation right here, as we can see, we can tell from the proportions, as you'll learn in the gas chapter, that as molar mass increases, the density will increase too, because they are directly proportional from each other. You will also see how as molar mass increases, since pressure is on the denominator value, it'll decrease, because when you learn in gas properties, you'll also see how other gas laws such as Boyle's and Charles' law will also play a role, and you'll see how direct proportions and inverse proportions will work later in this chapter. Alright, and that should be it. Thank you so much, and if you have any questions, please feel free to contact me and I'll be sure to answer as soon as possible.